section 3.4 on velocity and other rates of change. Day 2, our objective is to use derivatives to analyze straight line motion and solve other problems involving rates of change. And the other one you saw is using different things, including looking at a motion graph. So we're going now into acceleration. We were doing velocity. Now let's play with acceleration a little bit. This one here, acceleration, is the derivative of velocity with respect to time. If a body's velocity at time t is v of t equals ds dt, then the body's acceleration at time t is a of t, which is the derivative of velocity with respect to time, which is the second derivative of our position function. Okay, these are just a couple units to know, but usually they give you, when I say they, you know, math guys would be, they give you whatever you're working with. But if they give you metric units, but they don't say anything with regards to the free fall values, that's what you'll use. And for English, this is the one you'll use. Okay, so on example, this one here, a project is shot upward from the surface of the Earth and reaches a height of s equals negative 4.9 t squared plus 120 t meters after t seconds. Find the velocity after 5 seconds. So for velocity, we need our velocity function, which is our position function, the derivative of it, which gives us negative 9.6 t plus 120. There's our derivative. Bring the 2 down, multiply it with this guy here. T, the 2 minus 1 is just 1. And this is 1. 1 minus 1 is going to give us 0. T to 0 is 1. So we're just left with 120. There's our velocity function, but they asked us for the velocity at 5. So v at 5 would be negative 9.6 times 5 plus 120. When we throw this into the calculator lovingly, we get 71 meters per second. Yes, you must put your units on there. They gave you the units. They told you it's meters and in seconds. So at the velocity at 5 seconds, exactly at 5 seconds, this thing was moving at 71 meters per second. Okay, next question. A lot going on this one, but I gave you lots of room to write, hopefully plenty of room to write. So a dynamite blast propels a heavy rock straight up with a launch velocity of 160 feet per second, about 109 miles per hour. So pretty quick stuff there. It reaches a height of s equals 160 t minus 16 t seconds feet after t seconds. So this is our position function. It asks you, how high does the rock go? Okay, well, let's find out how high the rock goes. Now, the rock, what we're looking for really is like a max or a min. So in algebra, we would kind of play with that. But in algebra, we don't, or in calculus, we don't have to. In part A, what we need is when is the velocity equal to 0? That's going to give us at the time at which it hit its height, because that's when we're going to get a horizontal tangent, or in other words, this is when it changes from going up to coming back down the height. So we take our derivative. So let's go ahead and do our derivative up here because we'll need it a few times. So v of t is equal to 160 minus 32t. So for this first problem, I just wanted to take my velocity function, 160 minus 32t, and set them equal to 0. Now this is just going to give me how long did it take to get up there. So I need to solve for t, so I get 160 equals 32t. All I did was add 32t to both sides. Now divide by 32. And we get t equals 5. So that's how long it took for it to get up there, was 5 seconds. So how high does it go? Well, that's our position function. They are asking for position. So S of 5 is going to equal, go back to here, 160t. So 160 times 5 minus 16 times 5 squared. And from there we get 800 minus 400, which is going to give us 400 feet. So that's how high up in the air it went. So notice that this one here, t equals 5 seconds, and 800 minus 400 gave us 400 feet. So in 5 seconds, it went up 400 feet. Okay, part B on this guy. What is the velocity and speed of the rock when it is 256 feet above the ground on the way up and again on the way down? So this one here, they're giving you a position and they're asking what happens. So we have to start out with how long does it take for this thing to get up to 256 feet? So we're looking at position. So we're going to grab our position function, 160t minus 16t squared. And when does this guy equal 256? Anyways, now we have, unlike this one, they were asking us for a position. We had to find out how long it took to get there. This time they gave us position. We need to find out how long it took to get there, because it's not asking you how long it took, it's asking you for the velocity. Well, we have to know the time to get velocity. Now, hopefully you recognize that each one of these has a factor of 16 in them. So I'm going to just divide through by 16 so I can solve this thing. If I don't do it now, I'll have to do it later. So 10t minus t squared is equal to 16. Move everything over to the same side. So I get t squared minus 10t plus 16 equals 0. I basically subtracted 10, moved it over here, 10t, added 10t squared, moved it over here. But I like my 0 to be last, so I just moved my 0 over as well. So I factor this out. I need factors of 16 that add up to 10. It's going to be negative 8 and 2. So either t minus 8 equals 0 or t minus 2 equals 0, which means I have time t equals 8 and t equals 2. Okay, sorry, ran out of room. These are my times. This is the one as it's moving up because it's the first one. It's moving up, then goes back down. And when it comes down, it takes 8 seconds for it to go up and come back down until you get to 256. So now remember, they are asking you what was the velocity and speed of the rock when it was 256 feet in the air. This happened at 2 seconds and 8 seconds. So V of 2 is going to be 160 minus 32t, or 32 times 2, which gives us 96. Let's see, this is feet per second. That was the velocity on its way up. On its way down, we have 160 minus 32 times 8. And this time we get negative 96 feet per second. Well, the negative makes sense because it's on its way down. So if you didn't know before, now you do. Positive 96 means it was moving up, and then when it got to the very top at 400, it turned around and it started heading back down. Negative is identifying the direction. Now, they did ask you about speed, and since both of these answers are exactly the same, the speed on both of them is the absolute value of 96, or negative 96 on the way down. So if you wanted that. So the speed both ways was 96 feet per second at that time. A lot of algebra. I do realize this. A lot of algebra, but it's not like I didn't warn you. Okay, part C. Instead of going up, I'll read my paper. What is the acceleration of the rocket anytime t during the flight after the blast? Okay, well, acceleration is just the derivative of velocity. And our velocity function was 160 minus 32t, so our acceleration is going to be 32 feet per second squared. Because now we're just identifying it's going faster or the fact that it's moving quickly. That was part C. That was an easy one. Part D. It says, when does the rock hit the ground? It's a position again. So we're going to take our position function and set it equal to 0. So 160t minus 16t squared, when is it at 0? This is when it's on the ground. So I have 16 and t I can factor out, which is going to leave me 10 minus t equals 0. So either 16t equals 0, and that means t equals 0. So it was sitting on the ground before it got blasted into the air. And 10 minus t equals 0, which gives me t equaling 10. All I had to do is move the t over. So at 0 seconds and 10 seconds, the rock was on the ground. It took 10 seconds to hit the ground. So I want you to think about this as a worker, that somebody blasts a freaking rock up in the air. You have 10 seconds to make sure you're not in the landing zone for when it comes back down. Sound exciting, huh? So anyways, so it took 10 seconds. That's when it hit the ground. It says, when does the rock hit the ground? 10 seconds after the blast. Okay. So again, lots and lots of algebra. But a lot of the algebra you're going to find as you go through this, a lot of the algebra is going to be repeated algebra. You got to factor. You got to solve for 0. You got to solve for this. You got to solve for that. A lot of algebra. But notice the the calculus, you did the derivative. It's knowing what they're asking you for and how to get there. Okay, this is going to be the last example out of this video. It says a particle moves along a line so that its position at any time t greater than or equal to 0, is given by the function blah. There's our position function, where s is measured in meters and t is measured in seconds. They give us our units. Find the displacement of the particle during the first 2 seconds. Now remember, displacement is just delta y, or in this case, delta s. It's your change in y's. So you're just going to do, okay, we'll leave it as s of 2 minus s of 0, which is going to give us 4, because 2 squared is 4, minus 4 times 2, which is 8, plus 3. Minus, and I plug zeros in here, we get 0, 0, so we're left with just 3. So my 3's cancel out. I'm left with 4 minus 8, so my displacement is equal to negative 4. Okay, part B. Find the average velocity of the particle during the first 4 seconds. So now you're looking for that delta y over delta x because they asked you for average. So I'm looking for s of 4 minus s of 0 all over 4 minus 0. So we get from there, we plug in 4, we get 4 squared minus 4 times 4, which is 4 squared, plus 3, minus, put zeros in, I get 0, so I'm left with 3, all over 4. Well, guess what we get here? We get 16 minus 16 plus 3 minus 3 over 4 gives us 0 over 4, or just 0. So in the first 4 seconds, this thing did not get displaced. So he moved and then moved back to where he started. He did not. So, if you did something and 4 seconds later you stopped it, you're going, did he even move? If you weren't watching, your question is, did he even move? Okay, then they said, now let's look at this. We'll find the instantaneous velocity of the particle when t equals 4. So now we need our velocity function. So v of t is going to equal, can I push it? Yep. So derivative t squared is 2t minus 4, derivative constant is 0, and this is, don't forget, meters per second. But we want v of 4. V at 4 is equal to 2 times 4 minus 4, which is equal to 8 minus 4, or 4 meters per second. At velocity, it was the velocity at t equals 4 at 4 seconds when you're going to even move. It's actually moving at 4 meters per second. Now D is asking us to find the velocity of the particle when t equals 4. So this is just our acceleration. So the derivative of our velocity function. And so the derivative of t is just 2. But this one's going to be meters per second squared because they're going faster. So the time is. And then the very last question asks you to describe the motion of the particle at what values of t does the particle change direction. Now, even though we're going to get the same answers, kind of sort of on this, we are looking at velocity because we're being asked to describe the motion. So velocity of t, that's going to tell us when it's moving left and right. So velocity function is, I got to find them again on my paper, 2t minus 4. Now, it's going to be moving forward when 2t minus 4 is greater than 0. It's going to be stopped when 2t minus 4 equals 0, and it's going to be going backwards when 2t minus 4 is less than 0. Now, most people look at this going, we're going to get the same answer every time. Yeah, you will, kind of, yeah. So let's look at this, 2t minus 4 equals 0. So let's look at this guy here. That means 2t equals 4 or t equals 2. So at t equals 2. So moving forward, if I was to put a greater on this guy, is going to be when t is greater than 2. And if I put a less than on this guy, you're going to get t is less than 2. Now this is the one to watch out for because you can't do negative time. So this is really when 0 is less than or equal to t, which is less than 2. No equal sign here because the equal sign is here. No equal sign here because it's here. So really from the first 2 seconds, he moved backwards. At 2 seconds, he stopped and turned around and kept going and kept going and kept going. So does it describe the motion of the particle at what values? Really, that's what they're asking you. At what values of t does the particle change directions? Changes directions at t equals 2. It's moving forward when 2t minus 4 is greater than 0. That's going to be when t is greater than 2. And it's moving backwards when it's less than 0. So between 0 and 2 seconds, it's moving backwards. So if it started here, it went this way, and then it went this way. And you can see it did overlap here. Okay, this is the end of this video, a lot shorter. And so we'll get to we have one more video for this section, a lot more work going on with these. All right, good luck as you move through these.